Today we're going to talk about geometry since that is a huge portion of the praxis test. So to start with, we'll talk about the types of angles. So we'll start with acute, and that's going to be your smallest, and that's any degree measure less than 90 degrees. Next is a right angle, and that is any measure of exactly 90 degrees. And it's always denoted by having the box in the corner. Next is obtuse, and that's any measure greater than 90 but less than 180. Because once you get to exactly 180, you get a straight angle, which is also a straight line. The next is reflex, and that's anything greater than 180 but less than 360. And that's because 180 is a straight line, but 360 is going to be a circle, as we say here. So reflex is going to be anything in between the two. So a full degree of measure is exactly 360 degrees, which, as you can see by the dots here, forms a circle. So next we're going to talk about complementary, adjacent, and supplementary. So complementary means that the two angles sum is 90 degrees, and the two angles may not be adjacent. So as you can see in this picture, a right triangle, the two acute angles are complementary. So then, if we move on to supplementary, the two angles whose sum is exactly 180 degrees and that they may or may not be adjacent. So two intersecting lines, as seen here, always form two pairs of supplementary angles. So the purple ones are supplementary to each other and the pink ones are supplementary to each other. So in both of these we mentioned adjacent. So adjacent is when two angles that have the same vertex and share a side. So this one, as you can see here, is adjacent because they share this vertex, but they don't, and the side, because they share the vertex and the side. But this one is not adjacent because it's part of the side, but it's not part of the vertex. Next we'll talk about lines. So intersecting lines are lines that have exactly one point in common. Parallel lines are lines that never touch. Vertical angles are non-adjacent angles formed when two lines intersect, and the vertical angles are congruent. So as you can see here, angle ABD is congruent to CBE, and angle ABC is congruent to DBE. A transversal is a straight line that intersects at least two other lines, which may or may not be parallel. So as you can see here, this gray line is a transversal, and these two lines are parallel. This one is also transversal, but these lines are not parallel, but it's still a transversal. So next we'll talk about the sum and measure of interior angles of a polygon. So whenever we're finding the sum of the interior angles, we use the formula n minus 2 times 180, where n is the number of sides in the polygon. If we want to find the measure, we use the formula n minus 2 times 180 over n, where n is still the number of sides in the polygon. And we'll do some examples of this in the next video. So next we'll talk about the types of triangles. So there are three types: equilateral, isosceles, and scalene. So an equilateral, as you can get from the word equal, means that it has three congruent sides and three congruent angles. Isosceles is whenever you have two congruent sides and two congruent angles opposite of the two congruent sides. So for instance, if these two sides are congruent, that means that this angle opposite of that congruent side and this angle opposite of that congruent side are equal. So then we have a scalene, and that means that there are no congruent sides and all three angles have different measures. So now we'll talk about inscribed and circumscribed. So a circle is inscribed in a polygon if each of the sides of the polygon is tangent to the circle. A polygon is inscribed in a circle if each of the vertices of the polygon lies on the circle. A circle is circumscribed about a polygon if each of the vertices of the polygon lies on the circle. A polygon is circumscribed about the circle if each of the sides of the polygon is tangent to the circle. If one figure is inscribed in another, then the other figure is circumscribed about the first figure. So as you can see in this picture, we have a circle circumscribed about a pentagon, and a pentagon inscribed in the circle. So the last thing I want to go over is an arc length and sector. So the arc length is the length of a portion of the circumference between 2 points on the circle. The formula is S is equal to R theta, where S is the arc length, R is the length of the radius, and theta is the measure of the central angle in radians. So as you can see the picture here, we would be finding this arc length up here. So then next is sector. And sector is very similar to arc length, but instead of just finding this arc length, we're going to be finding this whole area. And that's what sector is. And that's all for today.